Hi, just picture this. Your application is running on AWS. It's 2 a.m. in the night, and someone messages saying that the site is slow. You open your dashboard, CPU is climbing, error rates are spiking, and logs are filling up with warnings. You know something is wrong, but what exactly and what do you do first? So, exactly that moment. The gap between seeing that something is broken and knowing how to fix it is exactly what EzyIQ CloudWatch is designed to close. Instead of spending 20 or 30 minutes manually correlating dashboards and guessing at the root causes, you come here, just simply click one button, and AI gives you a diagnosis, a severity score, and specific steps to fix it. Okay, so hi. I am Prasoon Tripathi with Vikas Kumar and Kamal Kumar. We are the student in the MTech AI and Machine Learning IIT Jodhpur. This is EzyIQ CloudWatch, a project for the virtual cloud computing course. So in the next few minutes, I will walk you through what it does, how I built it, and show you a live demo running in production on the render right now. Okay, so now starting with what it does. Okay, means just a feature overview means why exactly we made it. So EzyIQ CloudWatch does three main things. First, it collects real infrastructure metrics from the local machine using psutil and from AWS CloudWatch for EC2 data. And let me tell you, these all are real numbers, not fake data. As you can see, the screen is getting populated and the data is changing regularly every time. Okay, so it's a real data which I am getting from my local machine, that is local system, and with the AWS CloudWatch from the AWS cloud. This is my AWS cloud where the I have created the instance. Okay. The second thing which majorly this application is doing, sorry, it lets you simulate the exact scenarios like CPU spike, memory leak, network flood, disk pressure, everything. The system adjusts the metrics to mimic what those conditions look like in a real cloud environment. Watch how the severity badges changes from green to yellow and then red. So it will mimic the exact real-time scenarios there. Okay, so the third thing. What is the third thing? This is the key feature in our application. It sends all the metrics and log data to Grok, that is Llama 3.1 model, and returns an intelligent analysis, health score, uh, the severity level, the root cause, the recommendation. These are the issues, root causes. These are the recommendations, and everything in about just 2 to 3 seconds. So in simple word, in one liner, our application is collect, simulate, analyze. Right. Now coming towards the tech stack of our application, how it's built. Okay. So quick overview of the stack. Our application's backend is built on Python and Flask. Four main API endpoints. Root serves the dashboard. API metrics returns current values. API logs return the log entries. And API analyze calls the AI. For metrics, psutil reads the local system data and Boto3. Okay, so Boto3 is a SDK given by the AWS itself for integration with the Python. With the Python, we can configure and create the services. That is Boto3 has also been used in our application. Okay, that is for AWS CloudWatch Get Metric Statistics API for EC2, and both combined into a single JSON response, and that is getting polled in every 5 seconds. Okay, so this is the JSON response. I'm zooming it in so you can see that every data, everything is being provided here, being fetched. Okay, now coming towards the front end of our application. So the front end is very simple. It's a plain vanilla JavaScript with a chart.js. For the sparkline charts, no React, no Angular. For AI, I'm using Groq LLaMA 3.1, the instant model. Grok uses custom LPU hardware, which makes the inference extremely fast. That's why the analyze button feels instant. When you just click it, it gives you instant result within 3 to 4 seconds, just because of the LPU hardware. Okay, So before moving ahead, let me show you the directory structure. This is the entire directory structure of our project. CSS, style.cs, JS dashboard.js, templates, index.html, app.py. This is the main. Before moving ahead, as I told you, we are using the custom LPU hardware, makes the inference extremely fast here. So it's not anything simulated or fake. Exactly, we have configured this API key from Grok. This is a VCC project too, as you can see. This is the key which we have called real-time matrices Llama 3.18 model and real-time tokens which are getting used. Okay, so everything is getting used on the real basis. Okay, so done with the Grok part, API part. Now I have explained my front end as well. Now let's move towards the code part, the key code. So that has been developed there. You can see the entire folder structure over there. So let me quickly show you the two most important part of the code. So in app.py file, we are already in. The API matrix route calls psutil for local data collection. With the help of this utility, we are collecting local data. Okay, so you can see that we are defining things, and with psutil utility, we are fetching the local systems data. Okay, and after that, we are fetching the AWS data as well. So let's look for the Boto. Okay, so Boto 3 is the SDK utility we are using for fetching the data from AWS. Okay, EC2, AWS, all the data and things are getting populated here from the CloudWatch. Then if the scenario like CPU spike is selected, it overwrites the real value and simulate numbers before running them. Simple overridden pattern, very readable. Okay, so this is the pattern. And now coming to the next part, how we are doing the AI analysis here. So this is the AI analysis part. When you click the analyze button, which I have shown you in the application, this analyze button, when you click this button, so what is happening? Flask build a structured prompt. Okay, the Flask, the backend building a structured prompt with all the current matrices value and the last 20 log entries, send it to the Grok and get back a structured JSON response just within 3 to 4 seconds. And the key design decision is the output format. We are here telling the model exactly what 5 fields to return and make the response always parsable here. Okay, so we are getting everything: this health, the warnings, the criticality level, the severity level. So what main 5 parameters are to be asked? We have configured things here. Okay, so everything on the analysis screen is getting populated like health score, severity, summary, issues, recommendation, actions. So everything is getting configured here. Okay, so now let's give a live demo of our application. Okay, this is our application now. So here, this is the running live in production on render. I deployed my application on render, this one. So, okay, it's a real deployed URL. I can share with anyone and everyone. You can find it on my report as well. You can click it and you can also open this application. Anyone can open this one. You can see now, see here, you can see the metric cards and the data are getting updated live. Okay, this is live data. Let it refresh. Yeah, the things are getting changed or getting refreshed. Okay, yeah. The CPU, memory, network flood, disk pressure, everything, the network in and out, everything with a color coded CVT badges are there and a sparkline chart showing the trend. Okay, now let me click the CPU spike. Watch how the CPU card jumps to over 80 and 90% with a critical batch. See, it's a simulation of a runaway process. Now memory leak, memory climbs to the 80-90%, yellow and then red, simulating a slow heap leak. Now network flood, network matrix spike above 500 MB, simulating a DDoS surge. Okay, so these are the common scenario, disk pressure. So you can see the cards are reflecting the current status and data getting simulated at the live level. Right. Now let us check how the AI integration is working with all this data. This is the running normal screen. Let's do CPU spike. Badges are getting changed. yellow, red. Now analyze it. Now the main feature is here. This is a real API call to Llama 3.1 and the Groq LPU hardware. And now see how fast it comes back within 3 to 4 seconds with overall health score and exactly found what are the issues. AWS instance CPU uses 96%, error rate 11.28, disk uses high AWS response latency. At the same time, it has given every data, every metric to the Grok and returned the recommendations from it, like scale up the instance to improve CPU, monitor, debug error rate, free disk space, optimize AWS instance response latency. So here the recommended actions are the real value. Check for a runaway process with top or edge top. Review your order scaling, ground policy, consider restarting the services. I mean, whatever the things an engineer would spend 20 minutes figuring it out, the AI gives them just in 2 to 4 seconds here. Okay, now let me run it on the memory leak. To show it gives a completely different response. Now it's talking about the heap allocation, garbage collection, logs, and connection pool settings. Different scenario, different accurate diagnose should be there. Now let's see. From here, memory leak, you can see the badges has been changed. Now analyze. Okay, so the model is reasoning about the actual data here. High CPU utilization on instance, that is my instance on AWS, memory utilization, error rate on my instance. So it's a real thing which is getting fetched from recommendation from Grok this time. Scale up instance, consider adding more. So it is saving a lot of time of debugging at that critical moment for an engineer. So in this way, our application is working. And now the deployment part of my application. Okay, so I post the entire directory, entire application structure inside my GitHub repository. Okay, so it is here. And from there on, I created a web service and set pip install as my build command and gunicorn app as my start command. Sorry, as I hosted it on render, this one. Okay, so it took me around 2 to 5 minutes to deploy. So you can see that everything over here. This is my name, location. It has directly integrated with my repository, GitHub. Okay. This is my build command. Okay, so it will install every requirement and build it from here onwards. This is to start gunicorn app. And that is a feature even I was not very much aware of, auto deploy. So every time you commit any change, it is at the instant deploying the application with the latest changes that I find very useful in the render. That is very good thing. And okay, so these are the feature. And the second part, the environment, yeah, the environment variables. Okay, so you can see the Grok API key, AWS key, regions, secret access key, instance ID, everything are stored in render secure dashboard. It's not hard coded in my scripts, nothing, not in the .env environment. Yeah, maybe in local if you want to run, I have created .env file here, but everything is safely stored here. It is here for local. And for here, everything in the secure dashboard. So nothing is hard coded. So it make it secure and run means run it anywhere. So this is about the deployment of my application through Git and render. Now moving towards the architecture. So you can see that this is the simple architecture diagram. This is a 3-layer architecture. Nothing very complicated here. Here simply browser loads the dashboard from render. This is the render Flask server. So browser directly loading the dashboard from render. And every 5 seconds it calls API metrics. Flask call psutil utility for the local CPU data and Boto3 to AWS CloudWatch. And whenever you click analyze button in the application, okay, so whenever you click this analyze button, okay, here, so the Flask calls Groq API, return Llama response API keys, and those API keys are never exposed to the browser because of that functionality of what I say, render. It's very simple architecture: browser, app.py, dashboard, Groq API, and the services psutil for local, AWS CloudWatch, Boto3 for AWS CloudWatch. Okay, so now finally towards the result and conclusion of my application. So what does this project exactly demonstrate? See, traditional dashboards tell you the CPU is 92%, but here in the EzyIQ CloudWatch, it tells you what that means, what caused it, and what to do. And just within 2 to 4 seconds, it's at the same dashboard, you are already watching everything. It shows that combining real cloud metrics from the AWS CloudWatch with fast AI inference from Grok creates something fundamentally more useful for engineers. It saves you critical time at that moment when you were struggling at the most with a very, very narrow time window when you need to act. Okay, so what would be the future scope of this? Yeah, I think adding event bridge triggers to analysis files automatically on the CloudWatch alarms, extending to RDS and Lambda metrics, and using RAG to ground the AI recommendations in your own runbooks. Uh, these are some of the future scope of this. And EzyIQ CloudWatch is live at the URL on the screen as I have shown you. So you can give it a try. You can run it on your own system as well. It is accessible to all. And wherever you feel like that it is having more scope and you can share more knowledge with us, it is welcome to us. Thank you very much. This is Prasoon Tripathi with Vikas and Kamal again. This was our course project for VCC. Thank you. Thank you very much.